Hi. Yeah, we're gonna talk about databases today. So basically, this is the part of the project that we mentioned about databases. We did also inform that the one part of the project will be to look into database. So I will not recap anymore. For those who are interested, you can look back in the document that we introduced on the first episode in the words itself. Under one of the subject titles of learning is databases, which includes the different type of databases available. And today we're going to go into a little bit of understanding for the sake of those who do not fully understand what databases are and what is a relational database, what is a non-relational database, and also how these databases information can be retrieved and can be manipulated, and thereby helping us in our project. We will not talk about how to find the different databases today, but along the way, the project, we will look into another sharing session on how we find the relevant data that exists in existing databases that we can pull out and do our analysis on. All right, without further ado, let's look at today's sharing session. Okay, you should see on the screen just another one. You give it a little bit of permission to open up the slide. Permission granted. Okay, so today we'll talk about databases and what itself is exactly a database. So this is a definition of database on Oracle's website. You can actually read through it on Oracle, one of the database management systems available for us to actually look into. And what it actually entails is that databases are storage of information on computers. And this data can be utilized for us in a very simple method of query languages to request the information from there. So after reading all this through, so what exactly is a database? Okay, I'll break down that heap of behemoth that was written over there. Very clear cut here. What actually database entails is very simple. It's just related information. It's just information itself. Okay, so what do you mean? It can be anything from phone books to shopping lists, your to-do list, your 5 best friends, your Facebook user base, even the list of passwords that you keep in case you forget which password to log in for your hub, or which password you log in for your Facebook, or which password you utilize for your to-do list. So those are basically a collection of related information. And when we talk about this, right, where can you store these databases? Of course, in the real world, databases started off on pieces of paper. It can be even stored in your brain, in your neurons. Yeah, on a computer, of course. Like for example, this PowerPoint, I could store the information, or more structured, I can store in Excel, or I can store in Access. I believe majority of people would understand what Excel is. It's a table. And of course, what is Access? Access is a database that stores all this information. So having said that, what happens today in our current world is that computers plus databases plus the internet gives us a very interesting byproduct, I would say, short of a better word, of databases achievable everywhere, anywhere. The key part now is everywhere and anywhere. So databases can be stored online now on cloud services. So Oracle, as you know it in the past, they are very popular for doing databases, usually under SQL, relational databases. They have also got to cloud. I mean, correct. Don't quote me on this, but anyway, Oracle also have non-SQL databases, different lines of codes to do this. But we'll talk about this later as we go into relational and non-relational databases. But just to note that with the current implementation of the computer, the internet, and in combination with all the databases that we have, this is what we get in the current ecosystem. We can have cloud-based databases that we can query from, be it relational databases or non-relational databases, it doesn't matter. Google Cloud, Microsoft Azure, Oracle Cloud, AWS, Amazon.com. Okay, so now we touch on more a second layer of things down from the cloud. Okay, let's pull ourselves down from the cloud. Let's look at what is a database management system. Database management system is just software that helps you to maintain the database. Now, what do you mean by maintaining a database? This includes a few things, but what we always look at usually is the allow management of a large amount of data. So I can manipulate the data, a large amount of data at one go. Okay, it handles security, which is a pretty critical and crucial portion of it. Like, for example, I don't want anyone else to get access to my information if it's sensitive information. Or if I'm selling this particular database, I do not want any Tom, Dick, or Harry to actually come into the system and utilize the database. Of course, nowadays, we'll talk about this later on in another sharing session. A lot of these databases are open source. You just need to know whether it's relational or non-relational and what are the query structure languages that you need to use to get information from there. And thereby, after that, do CRUDs and manipulation of it. Okay. What other things you look into a database management system? You look at backups. Okay. You also want to prevent things from getting lost, information from getting lost. Is it stored on the server? Or is it stored in the cloud? Okay, there's a difference in it. Why? Because servers, if I burn down your server house, for some reason there's a fire and there's no backup to this information, your information can be lost forever. If it's backed up in the cloud, then I can actually still retrieve back the information even if there is no direct backup in a sense. Of course, the cloud does all the backup. I tell you, the cloud is a mysterious way. It's a very mysterious world. It deals with things in a very mysterious way. Okay, back to reality. We talk about import, export, concurrency. So I can do import and export concurrently. You look at the diagram. This is what we are talking about, data management system. You know, this is the database. The different computers can actually query it within an infrastructure, be it the internet or on an intranet. In the past, there were even very localized management system whereby the server itself is the computer that you are working on and you cannot access it from anywhere else. But nowadays, of course, with all this new infrastructure that has really been built up, minimally, we are looking at intranet capabilities. On the next sharing session for database, we'll definitely show you more clear. I will set up a intranet database system using MySQL. It's very easy. I'll show you how the setup is going to be done. It's a click of a button or few buttons, and then after that, I will use another computer on the same infrastructure to do query languages on it. Okay. Having said that, other things that we need to do on the database management systems includes CRUD, which is create, read, update, and delete. Okay, we'll talk about this a little bit later, and we'll talk about what are the different types of databases. I've been going on about relational databases and non-relational databases, SQL databases, non-SQL databases. Okay, we'll talk about this more in detail after this. Okay, so what is CRUD? Create, read, update, and delete. Main thing here is that you can create databases in your server. So you imagine the server is like a storage area for you to store maybe your to-do list and your shopping list. Okay, so you can create a to-do list and you can create a shopping list and put it into that storage area. And whenever you need to read the information, you must be able to read. When you want to update new things to purchase in your shopping list, or you to update something in your to-do list, you must be able to update it. You want to delete things off, you want to drop items off, you must be able to delete and drop off the item. So this is basically what we meant by CRUD. This acronym is very much utilized in database management systems all over the world, be it relational or non-relational. So just understand these are the acronyms that we will be utilizing. CRUD. Okay, then next thing you need to know is the types of databases we mentioned quite a few times: relational databases versus non-relational databases. So what's relational databases? What non-relational databases? Relational databases, or in short, some people call it SQL databases. Some and non-relational, sometimes we call it non-SQL databases. Put it very simply, SQL databases are just tables, and non-SQL databases are any other databases out there. Basically, if it's non-table. Okay, to make it more clear, let's look at what I mean by table. When we say table, we are really talking about table with columns and rows. Okay, just like the diagram show, a simple Excel table or any spreadsheet table. It can be Open Office, it can be your Google Sheet. It doesn't matter. So long as it's table itself, we consider this as relational databases. Okay. Second thing to this is that it must have unique key identifiers. What we mean by unique key identifiers, I mean, for example, information that can link all the different tables together. So I bring back the same example that I mentioned just now about your shopping list and your to-do list. Okay, for example, one of your to-do lists includes an item to be bought so that you can build your project. So that is also on your shopping list. And these two things can actually be related based on a key identifier. For example, I can put a foreign key on my to-do list to indicate this particular item, and I can retrieve that information from my shopping list to say, okay, I want to buy a Raspberry Pi, for example, it's on my shopping list, and it's on a primary identifier. Maybe I put a numeral 1, and on my to-do list, I will put my identifier as 1, 2. So this two information can be related, although it's on two different separate tables. Okay, we will see more examples as we go into practical, how all these key identifiers can help to correlate the information and thereby giving you more manipulation and CRUD powers and even analytic powers over all this data that is available. Okay, so now let's continue on what is SQL databases or relational databases. Interchangeable. Okay, so sometimes I'll say relational, sometimes I'll say SQL databases. Just forgive me if I keep changing, but basically these are the same thing. Okay, relational databases, we talk about the management system now, DBMS. Okay, relational database management systems usually there to help you create and maintain the database. Some of the examples are like, for example, MySQL, SQL Port, Oracle, Oracle SQL. Because now Oracle has Oracle non-SQL also. PostgreSQL, Maria database. All these are all SQL relational database management system. They will help you create database, and they will also help you maintain or manipulate the databases. And how do you maintain or manipulate all these databases and the data within? This is what we call query languages or query. We do a query onto that database. And generally, why we call relational databases SQL databases is because generally almost all, if not all, form of relational databases utilizes standard structures query language, or what we call in short SQL. And this SQL are standardized almost across all board, okay, to do CRUD, to do security, to do data query, to do manipulation. And it helps to define tables and structures, create the identification keys, correlate different tables, pull out information, and even do a small little analytics on it, and even pulling out graph. For example, the SQL server, POP SQL, actually allows us to do all this retrieval in a standard structured query language, and gives us all this information, including graphs. Okay, but just take note that while SQL is a standard structured query language, the standardization is as much as possible across a lot of boards, but not all boards. But however, if there is any changes, it will be slight differences. So just don't come in with the idea that this SQL server and that SQL server utilizing the exact same code would give me the exact same result. Okay, just before you confirm which code to use on your SQL server, just make sure that there is no slight differences. Usually, some of the different platforms do have slight differences, and you need to modify your code a little bit before you actually can utilize the similar code on another server. We will not touch into those differences unless, as we go along the project, we need to work on certain different databases, SQL per se, and with slightly different query structure. If not, this should not happen. I think more or less we will probably get in touch with more non-relational databases while we pull out this kind of information, because we will be dealing with a lot of timestamp and a lot of internet information, which usually will come in JSON. Okay, let's go on to what is a non-relational databases first before we even go into that. Okay, so non-relational databases, or sometimes we call it no SQL or non-SQL or not SQL databases. Okay, what are these? These are information other than tables. It can be JSON, it can be blob, it can be XMLs, basically online information, usually. Or it could be relational nodes, graphical relation nodes. Some of these high-level programming languages allow you to do certain kind of graph relational nodes, like for example, your fish diagrams, or even those nodes, different neural nodes that you can program it up for. So those are a different kind of graphical, or rather graph relational nodes. Then we talk about key value hash. Key value hash, for those who understand what it means, it's actually just information that is being hashed in by a function and then stored in a bucket, which can be integers, which can be values, can be strings, or it can even be JSON. In gist, it's like you go through a hash function and you store that information into a string of numbers, or hexadecimal. So this is one way of looking at hash value keys. For those who are involved with cryptography, or those, even better, if you're involved in cryptocurrencies, you will be very much in tune with this hash function, because one of the blockchain requirements is to solve the private key and the public key, which is actually a hash function. Okay, we will not go into very detail on all this information. First, it's just an introduction to what kind of databases are available. As we go along, if there's a requirement for us to go in depth, we will pull out another sharing session into what it is. For those who are interested, you can always Google up non-relational databases, and you can actually find out more. So what we want to bring along about this non-relational databases is this. The key part to non-relational databases is number one, it's implementation specific. So specific databases that's being built up to store all this information that's non-relational databases, they will have specific codes or specific language being set up to do the query itself. Okay, there are no set languages. There's no standard set language to say, okay, this is how we perform query on this relational or non-relational databases, non SQL databases. Okay, and you have to understand the CRUD function, the security function, the administrative functions, and the operations functions within the databases itself are also implemented based on their own programming language or their own software requirements, that the ones that have set up that database management system. For example, these are some of the different non-relational databases available, software available online that you can actually look into. One of the more popular ones are Mango database, MongoDB, Oracle non-SQL database, New. These are a few of those more popular ones. Okay, so for example, this information that you have put online and you want to retrieve the information as being managed by one of this database, non-relational database management system, say Oracle NoSQL database. So you have to utilize his own language to retrieve that information from that database that it was created for by Oracle NoSQL database. And if you use MongoDB's code to do that retrieval from this database, it will not work. They are just two different languages, and it's unlike SQL's structured languages, whereby the tweak of the query is just minimal across certain platforms. Majority of platforms have quite standard codings, if not slight tweak. It may be a total different manipulation altogether. But do not worry, we will find some ways to still manipulate this data. I mean, ultimately, whatever the case is, we can always still fall back on basic Python functions to do queries, bring out the information, and then from there, we can digest the information and do our manipulation on Python itself. Okay, that being said, I'm assuming that this information are the major information that we can see online, like JSON or XML or block, because Python has different script to still manage all this kind of information retrieval. So long as the scripts are available, we can still do all this kind of manipulation. However, if it ends up in a hashing situation, that itself could be a little bit harder, because that information itself will not be available to you unless you can have a key to open up the hashing and to reverse engineer that particular hash back to the original message itself. It's like an encryption. It is a crypto. That's why we call it cryptography. Yeah, it's an encryption of that information. Okay, so that being said, we're jumping the gun because we do not know what kind of information we'll be looking at in the databases. But as we move along, when we cross the bridge, we'll try to find different ways, and I will share online what are the ways we can deal with all this. If not, this is all we have today for sharing on databases. I hope this helped. I will also upload this set of PowerPoint online so that you can also see it. Other than that, if you got any questions or any information, please do DM me accordingly, and I will reply to you as and when I'm available. Other than that, that's all for today. Thank you very much for listening, and I wish you a happy 2022. Goodbye.